On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at an example of finding the derivative of a to the x. And a to the x, the derivative of a to the x, where a is greater than 0, is going to be a to the x natural log of a. That should sound a lot like the derivative of e to the x. The derivative d dx of e to the x is e to the x. We could say natural log of e to match up these e's just like I'm matching up these a's over here. However, natural log of e is equal to 1, so that's why we just say the derivative of e to the x is e to the x. Technically, we could put the natural log of e, just like over here I have the natural log of a. However, it is vital to include the natural log of a in our derivative, since a could be some positive number other than e. All right, so let's look down here at this example. I have some other pieces in here too, because you need to be careful. You need to be careful when you're finding derivatives of a to the x versus x to a power. Those two right there, I see students get those mixed up all the time. So here we go. What is y prime? Y prime is going to be equal to, let's take it term by term. The derivative of this first term, e to the x, is e to the x. It is very important to apply the chain rule here. The derivative of e to the 3x is e to the 3x, but then we have to come back and multiply by the derivative of this exponent, which is just going to be 3. On to this next term, plus 3 to the x power. This is where we have some number to the x power. So therefore what we have here, the derivative is going to be 3 to the x, but then we have to tack on that natural log of 3. That's where I'm applying this derivative rule right here. The derivative of a to the x is a to the x natural log of a. Therefore, the derivative of 3 to the x is 3 to the x natural log of 3. A is 3 in this case. Now on to this one, minus x cubed. This is just your basic power rule for derivatives. You pull the 3 down and you subtract 1 from your exponent. That's how I get that 3x squared there. Just be careful with your signs. And then last but not least, I have all these 3's in this example to kind of throw you for a loop, yes, and then to make you think about, okay, what are we really doing? Here we have some number a to a power. Now I'm going to call this thing right here a u. So I have 3 to the u, and I've used u quite often when I'm talking about chain rule. I could have called this a while ago, earlier, this right here, I could have called that u, where we would take e to the u du. We want to do the same thing with this here, but notice we do have the a to the some power going on, 3 to some power or some function of x going on. So therefore, our derivative is going to be minus 3 to the e to the x power. That is 3 to the e to the x power. It's kind of crazy saying that. And then we want to tack on the natural log of our base, which is 3. That's this part here. But now we need to come back and apply the chain rule and multiply by the derivative of this stuff up here. This is where I'm doing the du, the chain rule. And the derivative of e to the x is e to the x. Now there's no real way to clean this up and make it look any better, to be quite honest with you. I'll just come down here and rewrite it, maybe rearrange a few terms, and that'll be pretty much it. But this is pretty much our derivative. So all I've done here is I've taken that polynomial term, negative 3x squared. I wrote that first. I went ahead and multiplied these two pieces together. So we have that negative 3 e to the 3x. Good practice to put the coefficient out there up front if you want to call that a coefficient. And bringing that on down. And then that leaves us with this piece here and then this piece out here in the front. And since this term here and this term here both have an e to the x in it, it's not really helpful. It doesn't really make it look any better, but we can factor that e to the x out of both of these terms here, and that would leave us with a 1 when we factor e to the x out of that, minus 3 to the e to the x power natural log of 3. And notice that's what I have right here. And again, if you distribute that e to the x back to this term here and this piece here, you will get these two pieces here that I've underlined in black. So again, a to the x power, a is some number greater than 0. Be careful with that as compared to just the general power rule, like a x cubed, a completely different derivative, as you can see there, versus an exponential where we have some number to the x power, again, very different than x to a power that's a number. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.